Let us see push operation, that is inserting a element in the stack. There's a push function which takes parameter what is the value to be pushed. So top pointer, assume that it is global. Top pointer is a pointer of type node, just like first or head pointer of linked list. Now what we should do in push, check for full condition. For that, create a new node. Create a new node. If node is not created, then it is full. If node is not created means t is equals to null. When we are creating a node, t is null means node is not created. Then print stack is full. Printf stack overflow. Else, if suppose the node is created. So I will also draw it. Here the node is created. Then fill up this node, make this point on this one and move top. So inside else, I will write on, copy the data here, x value here. T's data is x. T's data is x. So suppose the value is 20. I have inserted 20. Then make this point on this node. T's next is top. T's next is top. So this will point on this one. Then as this is a new node, top should be brought here. So top should be brought on T. Top is assigned with T. Now remove T, we don't need it. So that's all, these are the steps. Simple steps are there, inserting a new node before head node or before first node, that same procedure we have followed, and the time taken is constant because the steps are simple steps. And this function works even if you are inserting first node. Let us check it. If you are inserting very first node, that time top pointer will be null. And if you create a node, suppose the node is created, this is not null, so come into the else part. T's data assign some value, so okay, assign some value. T's next is top, so what is top? Null, so this becomes null. Then top assign T, so top will come upon T. Then remove this T. Now you can see that this is the only node and the top is pointing on that node. So even if it is first node, it works, the same function works. Now let us look at pop function, deleting function. So we know well that deletion is done from this side, so we will delete this node. Let us look at pop function, how to delete. Actually we have to delete first node, but before deletion what we should check, whether there are some nodes or not. Means if it is empty, we cannot delete any node. So check for this condition. So I'll write here, if top is equals to null, then stack is empty or underflow. Printf stack is empty. Otherwise, we can delete a node. So let us see what is the procedure for deleting first node. Else. Now for deletion, I should have a pointer, some pointer here. Let us call that pointer as P. So I need a pointer. So I will declare a pointer also here, node star P. Then P assign top. So P should be pointing on first node. So P or T, anything you can take. I am usually taking P here. Now move top to next node. Top should move on to the next node. Top assign tops next. Then take out this data. P's data. Take out in variable X. Variable X. X assign P's data. So this data is taken in variable X. Then delete the node. So this node will be freed. Free P. Even I can write delete P or free P. Then the last statement also I have to write after else, that is return X. I should return the deleted value. There is no space, just I am writing here return X. So whatever the value is deleted, that value will be returned. If it is unable to delete, because if the stack is empty, then it will return -1. So if this function is returning -1 means stack is empty. Next, let us look at peep or peek operation. Now let us look at peek operation, which takes position and gives you the value at that given position. For example, if position is 1, then what is the value at 1 position in the stack? 20. What is the value at position 2 in the stack? 3. Or position 3, the value is 8. Position 4, value is 15. So this function takes the position and gives the value at that particular position. Suppose I want 10th position value. So first, second, third, fourth, fifth. Beyond that there is nothing. So invalid position. We cannot give a value, so we return -1. So let us see how this should work. Peek function takes a position. Suppose, for example, I have given position as 4. That is fourth position. Fourth position means 1, 2, 3, 4. This is the fourth node. I want to know the element present here, that is 15. So for that, I should traverse through this linked list starting from top node or the very first node. So for that, I take a pointer P and make it point on top here. Then to reach fourth node, how many times P should move? 1, 2, 3. So it should move for 3 times. 1, 2, then 3. So after moving 3 times, it can reach on fourth node. So by using for loop, I will move P until it reaches that given position or it has become null. So I will write on the code here. See, I is starting from 0 and I is less than position -1, I plus plus. And before that also I am checking P is not null. If it is null, then we don't have to go beyond that one. So also check whether it is becoming null or not. Then move it for position -1 time. So for moving, P assign P is next. So this will be moving P to next node every time. So this for loop will take P upon that particular position if the position is valid. If it is invalid, P will become null. So I should check whether it is valid or invalid. So after the loop, check if P is not equal to null, means it is valid. Then return the element at that position, 15. Return P's data. This is not deleting, just we are sending the value, copy of a value. If it is null, then return -1. Else return -1. It means that position was invalid, so we don't have data there. That's all with this peek function. So we don't need this X. I have already declared initially, but we don't need it. So we have directly returned the value. Instead of taking an X and sending it, I have directly taken the value. So this is a peek operation. That is finding an element at a given position. Now remaining small operations are there, that is stack top, is full and is empty. I will directly write down their code and just quickly explain you. So here I have a stack top function. Stack top, if top means top is not equal to null, then return the data present at top. So it returns the data. Otherwise, it will come to this statement and return -1, means data is not there and the stack is empty. Then is empty function. If top is null, then it is empty. Otherwise, it's not empty. If top means top is not null. Not null means return 0. Else means it is null, so return 1. 0 means false, 1 means true. So if top is not null, then return false, otherwise return true. Then is full function. For checking whether it is full or not, create a node and check. So create a node and check if that T is not null. If it is not null, assign 1 to R. Otherwise assign 0 to R. 1 means true, 0 means false. Means if it is not null, assign true. Otherwise assign false. And after that, delete the node and return R. So whatever the value was stored in R, that will be returned, true or false. So that's all. These are the functions for stack. So all the operations we have seen, and every operation take constant time. All are simple functions. So whenever we need a stack, we may be using either stack using array or we may be using stack using linked list. Whichever one you want, you can use that one.